Can humans regenerate their limbs? Sounds like science fiction. Well, it's not. As this next story will show, the future is most definitely here. South Florida, 2009 is a typical day for the Mraz family. Father Froilan goes outside to wash the family car. He's accompanied by his two small sons, Froilan Jr. and 14-month-old Jiva. Their mother, Jeanette, is inside. What happened next was the beginning of a bizarre journey into the scientific unknown.
He was stepping out, he was coming out from the house to the outside when Ivan was following him. He never noticed that Ivan was behind him. He shut the door like a normally kid will do, and Ivan was grabbing the edge of the door, and he shut the door.
In an instant, Jivan's right thumb is cut off just below the nail.
I grabbed some rag, the towel from the kitchen, so I put it around his finger.
Yes, we were like, we need to rush, yeah, because he was losing a lot of blood. I believe she was on her second towel, no blood. So yeah, we just rushed to the hospital.
As they rush to get medical aid, Jeanette and Froilan have no idea just how badly injured their baby son is. Doctors treat Jivan's injury, but they tell his parents that since the rest of the thumb is missing, the boy's hand will be disfigured for life.
We were at the hospital and waiting for the results. The doctor told us that probably he was gonna lose his thumb, and that was a bad news for us at the moment.
The Mraz family is devastated. They believe their youngest son will be permanently scarred and partially disabled. But days later, the pediatrician offers some hope. He sends them to a doctor named Juan Bravo. He has a controversial new treatment known as pixie dust. He thinks it could improve Jivan's condition.
The product is simple. It's a powder, and it's applied to the wound bed. And pretty much you reapply every 24, 48 hours, and the tissue regenerates underneath it.
Could Jivan's finger be saved simply by using a magic dust? It's an extraordinary claim.
We called the mother, and I remember I called her and said, listen, we've come upon a product that is supposed to be great for fingers. I got pictures to show you. It should not have any side effects or any future complications for him, and we would like to try it with him. And she was all up for it.
But the powder has never been used on a baby before. With no guarantee of success, Jeanette and Froilan would have to take a risk.
It was the first time that they had used that on a baby. So, I mean, I believe that it was a first trial, and we give them the yes.
Knowing little of pixie dust's mysterious healing power, just days after the first application, Jeanette and Froilan checked Jivan's wound. What they found was astonishing.
We started seeing that his finger started to get a shape. We were surprised. We never thought it was gonna work.
And we applied powder every 48 hours for the first 2 weeks, and then we spread it out to 3 times a week the third week. And there really was no need after the third week.
It seems like science fiction. In just over 3 weeks, the seemingly miraculous had occurred. After severing his digit, Jivan's thumb has grown back, nail, fingerprint, and all.
It looks like 99% equal to his left thumb.
When we finally removed the scab that was formed by the magic dust, what was underneath it? It was normal skin, it was a normal finger. It was like it never happened. It's hard to believe that this finger was going to regenerate that fast and heal that fast.
I'm very happy. Yeah, I felt very happy to see that his finger growing.
But did the powder alone regenerate Jeevan's thumb? If so, how? Many pediatricians and other medical experts are skeptical. They believe the fact Jeevan's thumb regenerated is not that surprising. It's an ability that starts in the womb.
We know that that pretty serious injuries in fetuses can be completely healed normal like there was never an injury. What we do know, and I think everybody would agree, is that young children, for example, if they cut off the tips of their fingers, they can occasionally regrow them. That's not a miracle. It was going to happen anyway.
But then, something extraordinary happened.
What is less easy to explain is when you get an individual like a Lee Spivak.
In 2005, Lee Spivak, a 64-year-old man, had the tip of his finger cut off in a gruesome accident caused by a model airplane propeller. Weeks later, his finger grew back. It was possibly the first documented case of an adult regenerating a body part. Remarkably, Lee Spivak's doctor suggested using the same powder Dr. Bravo applied 4 years later on Jeevan. Had the pixie dust now regenerated an adult human finger? Dr. Ashkan Giovanni is a plastic and reconstructive surgeon. He believes this kind of regeneration in humans is not possible.
Well, limb regeneration itself is more possible in salamanders and the lizard family. In human beings, you can regenerate skin, but to actually regenerate all the parts of a limb, the bones, the skin, the soft tissue, fat, tendons, nerves, that's impossible for that to occur.
Steve Badylak is a research professor from the McGowan Institute for Regenerative Medicine.
Extracellular matrix is the glue that holds all of the cells in our body together. All tissues, as most people know, are made up of cells, different cell types, skin cells, muscle cells, heart cells. So extracellular matrix is what you might think of as an instructive template that all the cells in which all the cells of our body live. We can make powder forms, we can make forms that look like sheets, we can make gels out of it, and these are important for different therapeutic applications.
Extracellular matrix is the scaffolding upon which all tissue in the body is built. This mix of protein and connective tissue can signal the body to start the process of regrowth if applied to a wound. Some scientists even believe it may be possible to use extracellular matrix to regrow an entire digit or limb.
It changes the default mechanism of healing of the body. It's something that basically Mother Nature's been working on for hundreds of millions of years of R&D, if you want to think of it that way. So we're just harvesting it and saying, okay, we know we're never going to do as good, so let's just see if we can collect this stuff without messing it up.
So where do scientists get their ECM? Well, here's a clue. It's a cute, cuddly pink farm animal that just happens to have loads of therapeutic ECM, perfect for regrowing limbs. Yes, no brainer. It's pigs. But why?
Pigs are a convenient and abundant source of extracellular matrix. The tissues from which they're made, like skin, small intestine, urinary bladder, are throwaway products of the agricultural industry. So here's a tissue that would have been waste or maybe turned into fertilizer. We're now using as a medical device, a regenerative medicine tool for reconstruction of tissue.
Pigs are genetically similar to humans. Because of this, proteins found in their bladders can trigger a response in us. But how do they harvest it?
So to prepare the extracellular matrix, we start with the raw pig bladder. And then by using an acrylic scraper, we simply spread the tissue, loosen the muscle fiber. Using forceps, then we grab that muscle and literally pull and tear it away from the underlying matrix. So that's the outside layer, which is referred to as the abluminal layer. That's where the muscle was attached. It then goes through what is referred to as a peracetic acid wash. At the end of that stage, the ECM is ready for use. It can be freeze-dried and used as a dry sheet. That sheet then can either be used as is or be ground into a fine powder.
But not everyone is convinced that ECM is the answer to this mystery. Rocky Tuan is the director of the Center of Cellular and Molecular Engineering. He believes There's another explanation why Lee Spivak and Jivan's fingertips grew back. They may have a unique genetic predisposition that enables them to do it.
Possibility of regenerating finger is definitely there, as shown by Lee's results. He may very well have a genetic or maybe even epigenetic constitution that allows him to respond in this manner.
Is it possible that people like Jivan and Lee are able to regenerate while most of us can't? Could we exploit their incredible ability? Before we can find the answer, far more research needs to be done.
What we're trying to do is trying to figure out how, in rare instances, people are able to grow, what the mechanisms are, and then also in situations where they can't regenerate, and then try to compare the two. And by doing so, we hope to identify those factors or cells or genes that are responsible for this process. And that's how we can move forward.
One way this may be possible is through stem cell research.
We can instruct the body to regrow a body part, then why wouldn't we do that? I don't think there's any doubt that someday we will be able to control the way cells act in the body. In other words, we will be able to instruct the growth of new tissues and organs. But what we would like to do is be able to regrow your heart if you have a heart attack that destroys so much of the heart muscle that you're going to die. Or to replace your kidney to get you off of dialysis, or to regrow your esophagus so that you don't have to go through a life of misery after having it removed. Instead, we will grow you a new esophagus. This is not science fiction. It would have been science fiction 30 or 40 years ago.
Could this eventually lead to the holy grail of all scientific discoveries? Could this give us eternal life?
The fountain of youth. It has always been the holy grail. We may change the life expectancy. If you're able to better locomote because you have better limbs and joints, you'll be more fit, for example, and maybe you eat better and feel better and so on and so forth. It'll probably affect your life expectancy.
Imagine a world where no one gets old. What will our civilization look like in 100 or 1,000 years?
What the